All right, so in this video, I'm gonna briefly go over the stuff that we've covered in semester one. This is the stuff that you should be familiar with as we go into semester two. Okay, stuff that you should probably be relatively confident in. Okay, so the first thing we did in semester one, unit one, the main focus of that was to review algebra 1A. So algebra A review. Okay, and that covered a bunch of different things. I would say that the two biggest things are solving equations and graphing something that's in mx plus b format. So I'm going to go through kind of two quick examples of what that was like. So something like this, negative 9x plus 18 equals 4 times x minus 15. So this question has a little bit of everything, but it's a good example of the kind of thing you should be comfortable with as we kind of go into semester two. Okay, so obviously the first thing you'd want to do here is you want to start off with that distribution. All right, so we're going to multiply this out, and then we didn't change anything on the left, so bring that straight down. Okay, but we did change the right hand side. 4 times x, 4x, and 4 times negative 15, negative 60. Okay, now I'm going to go kind of quick through this just because this is kind of like a recap video. But if I go too fast, feel free to pause and catch up as we kind of go through it. Okay, so again, this is not new stuff. This is stuff we covered last semester. So hopefully the things we kind of do is familiar to you. Okay, so the next thing we look at is this equation has x's on both sides of our equation. Right, we have a negative 9x on the left, and then we have a 4x on the right. We need to get the x's to one side. Doesn't matter which one we move. We gotta move one of them. My preference is always to move the smaller one. So I would do this. Because it's a negative 9x, and that's smaller, I would move it to the side by the opposite, adding 9x. Again, both sides. You could, if you wanted to, move the 4x, you could subtract 4x both sides. It's really your preference. I always move the smaller one. Okay, so leftovers. So these are gone, but we still have that 18. And on the right, 4x plus 9x gives you 13x, and we still have that negative 60. Okay. Now that x is on one side, the numbers have to go to the other side. So because I have the x's on the right-hand side, I got to get rid of that 60. So the opposite of a negative 60 would be a positive 60. So notice we just keep moving things around until we get x equals. That's the goal. Okay, these cancel. Now we have 13x equals 78. Okay. And then we need to get rid of the 13. All right, it's attached. Remember when anything's attached like that, the opposite would be to divide it to the other side. Okay. And then if you need to use a calculator, like never feel ashamed to use a calculator. It's perfectly acceptable. So plug in a calculator. 78 divided by 13 gives you 6, and that would be our answer to this equation. Okay. The one thing I want to point out, which a lot of students last semester lost points because they didn't do this, was notice all these, I did it in purple on purpose, all these little purple steps, I'm showing exactly what I'm doing from one step to the next step, right? The first one, I'm moving 9x, I'm adding it. The second one, I'm adding 60. The last one, I'm dividing by 13, okay? You have to be showing those steps to get full points. Because I know if you guys try to use photomath has line by line, but it doesn't tell you exactly what's happening. It just goes like result one to result two. It doesn't say how did they go from one to the other. So that's what I'm looking for to get full credit for solving equations. Okay. The other big topic from Unit 1 was graphing. Let's see if I can fit it in the same space. I'm going to draw a line right here. Maybe I can move it over a little bit. Okay. And the main one you want to make sure you can remember how to graph is mx plus b. So let's say the question was graph y equals negative 3x plus 5, right? So that's in our mx plus b format, right? Y equals mx plus b. And it's fairly easy to graph this as long as you remember what each piece does. All right, so we can go ahead and draw like a small graph. Okay. And remember, the key concept here is making sure you guys know what does M do and what does B do. Okay. So M in this case is that -3, right? So it's always mx. So M is -3. And B is +5. Okay. And the way I always tell students, remember, is you begin with B and then you move with M. So the B is always our starting point, and it's always 0, 5. So 0 and then up 5 spaces. So our first point is here. Okay. And then we use M to move to our next point. Now M should always be a fraction. Right now it's not. So to make it a fraction, just put it over 1. Remember, the top number is always your up and down value, and the bottom number is always your left and right value. So this is telling you to go down 3 spaces and then right 1 space. So from that top green dot, I'm going to go down 3 and then right 1. So 1, 2, 3, right 1, right there. And because these are straight lines, I only need those 2 points. So draw that line, and then we're done. Okay. So overall, these 2 examples that we just did, that's the main thing I want you guys to remember from Unit 1, which now that I realize I didn't even put a 1 up here. Let me go. Unit 1. Sorry for the bad handwriting. Okay. As we moved into Unit 2, okay, let me scroll down. Unit 2 was all about exponents. Okay. And it's the idea that like algebra A is all what's called linear algebra. Everything was a straight line. And then as we get into algebra B, we start to include these exponents, which cause our graphs to become curves, right? They're no longer straight lines. There's a curve, okay? So the things you need to remember from here was we had a whole list of exponent rules. So make sure you guys know your exponent rules. That's the first thing. Oops. Okay, so if something has a negative exponent, make sure you know what to do with it. Or if it has a 0 power or power to a power, make sure you guys know those rules. Because then what we did with that was we had these exponential equations, right? Where the exponent is the variable, okay? So we spent a lot of time going through questions like this where it said, complete a table and graph. And then they would give you a specific equation, something like this, where it's f of x equals 3 times 2 power of x. Okay, notice the big difference here is that the x is an exponent here. Versus, let me scroll back up to Unit 1 very briefly. All of these, x is just like a normal number. So linear algebra looks like that. Exponential algebra looks like that, where the x is in the exponent position. And the idea here was we set up a table, right? So we have x and f of x. And we always use the same values, right? Just because we want a general idea of how this is going to look. And if you guys remember, there's a general structure to these, right? They have a starting direction, and they either curve up or curve down. But usually you can get that idea from these few points. So -2, -1, 0, 1, and 2. And the idea is to plug those values in and see what comes out. Okay, so if you're plugging in -2, it would look like this. 3 times 2 power of -2. So here's where those exponent rules come in. You have to know, well, what does a negative exponent do? Remember, it causes the number to change sides. Okay, so it's going to turn into this. That 2 is going to flip around and become 1/2. and now it's power of positive 2, which we can do. Okay, 1/2 squared is just 1/2 times 1/2, which becomes 1/4. And then you can multiply a whole number times a fraction. Multiply those straight across, we get 3/4. Okay, so that would be like our first point. And then if you guys remember, there was a pattern to these things, right? The pattern had to do with the b component here, right? These equations were always a times b to the power of x. The b value is essentially telling you what the pattern is going to be. It's telling you that our pattern is, because it's a 2 here, that means our pattern is multiplying by 2 each time. Okay, so you could just plug in -1 and see what comes out. Or we could use our pattern. We know it's going to be multiplying by 2. So 3/4 times 2 ends up being 3/2. Okay. The 0, I mean, that one we kind of already knew. Remember, we always knew it's always 0, comma a, whatever a is. So we already knew this one was going to be 0, comma 3, because a is 3 from up here. Okay. And we just keep using the pattern the entire way down. So times by 2 again, so we get 6, and then times by 2 one more, and we get 12. And if we kept going, it would be what, 24, 48. We just keep multiplying by 2 each time. And then once we have this table established, we could easily just draw a graph, and then we're done. So let's draw a quick graph. Okay, and we kind of plot those points. So the first one, -2 3/4, kind of about there. The next one, -1 3/2, about there. 0, 3, about there. So you can kind of see how it's curving now. It's slowly going upwards, but then the next one's a huge jump, right? 1, comma 6, way up here. Okay, so it's growing very, very quick. So you have to remember that it always starts very, very close, and then slowly curves, and then grows very, very quick. And then we're done with that kind of question. Okay, so that's kind of the main thing from Unit 2, was making sure you guys were comfortable with exponents and able to graph these exponential equations. Okay, so that's all of semester 1 in a nutshell. Okay, obviously we did a lot more than that, but that's just broken it down into about 10 to 15 minutes or so. Okay, so that's the stuff you want to make sure you're comfortable with going into semester 2. We did a little bit of the polynomials, but that's where we're going to start for this upcoming semester.